Hello guys, it's Mihai. I would like to share a few thoughts that came to my mind while doing the long overhaul of my MD6 engine for Albin Vega number 1574 Kispal. Let's start from a situation that we all know. If you want to move our boat while we stand on the land, we would feel the force that we use to push the boat in our hands, but also the same force we would feel within our feet. That's according to Newton's third law, action-reaction, and they would be equal. The same applies to the propeller. When the propeller is rotating, it generates a force against the water, and then it's sending the force through the rotating shaft towards the boat, where it goes further. Of course, it goes to the engine, and then through the engine mount, it goes to the hull of the boat. The shaft is rotating, the engine is not rotating in general, so there must be an interface between the rotary and the stationary parts. That interface is called the bearing, and I would like to speak more about that part. So that's the bearing we are speaking of. And let's see how it looks in our particular case. So this is how the shaft with the combi mechanism looks like. So here we have a flange that connects to another flange that's coming out from the engine. Again, force, equal force at the other side. In the parts list, this is the flange I was showing you before, and here is the counterpart of the flange with a planetary drive coming straight out from the crankshaft of the engine. In the reality, that part looks like this. And here is the mounting holes for the flange. There are two bearings holding that part, and this is rotating, right? So this is still rotating, and the stationary part receiving it is this one. You might know it looking from outside at your engine. You might remember it well. And the interface between those is two bearings. One is this one. I have to mention that's the craziest part in our engine. So if I would to manufacture it, anything from the engine, this one would be the craziest, I think. Or maybe some of the castings, whatever. So if we assemble this, it's not that easy. Okay, you see, I'm able to slide it actually. So is that bearing capable of transferring any actual force? Obviously not. We have another bearing, this one. Luckily, and it comes here, right? I won't assemble it now, but it goes here. Here is, you can see the mark that it made due to the axial force on the part. Luckily, this one is a replaceable, standardized bearing. Its number is 6013. I already bought some new bearings, here you can see, and I will replace this one because it's noisy, and also I feel some, not continuous things like ticks during the rotation. Okay, so that bearing transfers all the load that pulls our boat forward. Now let's think about it, how much that force can be. Here is a short calculation. So our MD6 is 10 horsepower, which stands for 7,400 watts. Let's say we travel at 6 knots. That's about 3 meters per second. Of course, there are a lot of losses in the propulsion, and also the direction of the propulsion is not always horizontal. Usually it's not perfectly horizontal, so we have losses from the direction of the force too. And the propulsion itself has its own efficiency, which depends on the rotation speed of the propeller, of course the geometry of the propeller. Here are some examples from the internet. So based on this one, let's assume that our propeller would be somewhere, let's say 65% efficiency. Okay, so following the calculation, here is the power output reduced by the efficiency equals force times speed. After doing the math, we get 1558 newtons. Well, obviously it's much more than we would use in that situation, but remember that the drag force around the hull is increasing rapidly with the speed, so we would need definitely much more force to develop 6 knot speed. Okay, now let's think about what such a force means for that particular bearing. If you go to the SKF website, you have the data sheet of the bearing, and they would present you different calculations regarding that bearing. And there is something like basic static load rating. We'll be looking at that further. Oh, it might be difficult to read. I'm sorry about that. Now let's neglect the force from the planetary gear that makes the radial load on the bearing and just consider our actual bearing that comes from the propeller. So pure actual load needs to be less than half of the C0 parameter. C0 here is 25 kilonewtons, 25,000 newtons. Half of that is 12.5. So it means that we are roughly around 10% of the allowable static load. Does it seem to be able to wear out our bearings? Not really soon. I believe that the factor that might affect my bearing was contaminated oil in the engine, as those are lubricated by the oil, or maybe some hammering on the end of the shaft, as everything you make here would go straight to the engine and affect this bearing. It's not really expensive, but it's worth to pay a lot of attention to it and replace if necessary and if you have that possibility. Thank you very much for attention. I will share some other thoughts that came up during that repair soon. I'm sorry about the bad quality, but I really don't have time to make nicer movies. Cheers.